Welcome back to the EKS Anywhere bare metal video set. And this time around, we are going to do a video on how to deploy a bare metal cluster for EKS Anywhere with Red Hat Enterprise Linux 9.2. So I'm joined by my colleague Raj again. Hi, Raj. In the
Hello, everyone.
previous video, we've done two, right? The first video really talks and unpacks the under the hood of the Tinkerbell workflow and the cluster creation. And the second video was about how do we do a bare metal deployment for EKS Anywhere with Ubuntu. And in this video, like I said, we will do it specifically for RHEL 9.x, right? So allow me to share my screen and we will do a quick recap again in terms of our lab setup. The lab setup stays the same. If you watch the Ubuntu video, I have detailed out, what's there in the lab, but just to kind of, overview our three bare metal servers, which will be the part of the cluster as such, one control plane and two worker nodes. All three of them have the Broadcom card, which is supported in terms of compatibility with HookOS. We have the SATA controller here with the SSD disks in a RAID configuration. We do have our NVMe disks here for the worker nodes. The iDRACs are set up on the 197 subnet for all the three servers. The intended IP addresses for these NICs, which will be a part of the cluster node. It's a 198 subnet, which is also where our admin server sits, 198.72, essential to, again, emphasize that these have to be in the same layer 2 broadcast domain for the Tinkerbell and the DHCP and the Pixie boot to work seamlessly. Our web server is hosted with 73, and it's serving the image files. Last, we did it with Ubuntu. This time, we are looking at the RHEL. So this file is already present in the HTML directory so that when the booting starts, the OS can be downloaded from here locally. Plus, we do have the Hook OS images, the two artifacts here under the subdirectory of Hook, actually. Okay, so this is pretty much what it is. We will again, the process will remain exactly the same. Okay, so if you watch the Ubuntu video, the process practically remains the same. What differs is now that the OS distribution is going to be a Red Hat one. So why are we doing this video? This is the first time I would say such a video would exist. I have scavenged the internet, in terms of YouTube or whatever. Practically, there is no video or a blog that articulates or demonstrates an end-to-end workflow or a proof pointing saying that Red Hat, RHEL clusters for EKS Anywhere bare metal can be done. There is the official guide. Definitely one can follow that. But as such, there is no shareable knowledge of an end-to-end experience, right? So feel free if you are in the midst of playing around and tinkering with a Red Hat-based cluster for EKS Anywhere on bare metal, this should be your video. So like always, we will first see go through the artifacts. So Raj, I'll ask you to request you to share your screen. So we will look at so this is again our admin server. I have time and again said that it doesn't matter whether your admin server is a Ubuntu host or a RHEL host. You can create a Ubuntu or a RHEL target cluster for any of these kind of configurations on the admin node, right? So we have the admin server here. Plus, let's look at the hardware.csv just to kind of go through this again. Again, most of this has been already established in the previous videos, but just looking at the hardware.csv are three nodes and each line represents the node input. You have the MAC addresses of all these three nodes and the DHCP reservations that should be awarded to these by virtue of the Pixie boot and all that, actually, right? The type, this is important. In the last video, I've not emphasized, how you can play around with this type as in CP worker to really establish some of the node group concepts and all that. We will do that in a follow-up video on later, but essentially the type CP here and type worker for, these two nodes actually. The disk information, what else, right? The iDRAC is there, for the admin node to communicate with these. So this becomes your hardware.csv, which is the inventory file. Let's also now look at the cluster configuration. And we will intentionally, we've kept it to the Ubuntu state. Now let's see. So let's get on to the editing mode. And we will edit the parts and portions where the cluster configuration needs to reflect that this is going to be a Red Hat based cluster actually. So Raj, we can edit this one. So we are editing the cluster configuration file. And we will scroll down to the section where the OS image URL in the Tinkerbell data center config exists. So slightly up. Okay, so first we will edit the machine configuration and change the OS family to Red Hat in both the control plane and the worker node machine template. So you can see that it's all small. And instead of Ubuntu, we have made it as Red Hat. And then change the image file name. The previous one was Ubuntu. And this time around, we will put it for Red Hat, actually. So practically, if you look at it, these are the only couple of changes that we need to do. Everything stays, pretty much same. One is the OS image URL to actually indicate the right file for Red Hat. Second is the OS family under your machine configurations for your control plane and your worker nodes, right? With that said, it's also important that your OS image is, adequately built beforehand and it's kept in the web server. There's a separate video blog that done of how to create the OS image for, Red Hat for EKS Anywhere on bare metal with UEFI support, right? So you can watch out that particular video of how to build the OS image. But once that's built, this is what the path looks like, and then whatever changes that we did. Let's save this file. And what we are doing is, since this was a set of nodes which was used in the Ubuntu cluster installation, we've already cleaned up this particular node in the sense that the virtual disks have been deleted and recreated. And I've again emphasized this time and over again that you're going to redeploy a cluster on an existing set of nodes which were used in the previous cluster configurations. Please make sure that your virtual disks are recreated. It just kind of helps with any errors or that might creep up actually. So this is I would say a clean set of nodes as such. And another thing is, in the last Ubuntu cluster creation, we had kept the verbosity level as the highest as 9 this time, and that gave a flurry of logs, right? And it was good for you to understand the how do we substantiate the workflow from a visual perspective, right? And I kind of indicated what happens actually to the extent that we could, given the flurry of logs. This time around, we will keep it simple. We will not pass any, so we'll keep the default verbose settings so that it becomes a very clean, step-by-step, whatever, a typical workflow being showcased by EKS Anywhere of what's happening. The only thing is that, since you will not get much information, it's quite possible that the overall cluster creation typically takes about 40 odd minutes. So yeah, your step would be hanging in there, right? So if you see a flurry of logs, you know something is happening. But here, really, it'll kind of stay stuck at a certain step and then move along. But that's okay. At least by the end of the cluster creation, you will see in summary what all steps have been done. And the same applies to the Ubuntu cluster. It's just that there we have kept the verbosity very high. So the command is the same to create the cluster. EKS Anywhere create cluster. Hardware.csv is the inventory file that we are passing, and the cluster config to which we've just made the changes, right? Again, we will open the second terminal also, keep a parallel track. The same thing of the bootstrap cluster invocation will happen on the admin node. So we will see that kind cluster and then move on to the iDRAC consoles or the virtual consoles of all the three servers to see the initial boot process and things like that, right? Till the cluster comes into formation. Okay. That said, let's begin. Let's roll in. Okay. So you can see that the cluster creation has started. It does give we are in a demo setup. Yeah, ideal number of control plane nodes should be 3 or 5. We are really, at one node. The first things first is the validation of the template. So the template, whatever changes that we did are still intact. I mean, those are valid enough. And hence it actually goes to creating the new bootstrap cluster. And since you're not seeing much logs, the idea is that, if you go to the other terminal, Raj, on the admin node itself, we will see the Docker PS there. And we will see the two containers will pop up. You can see the lifespan of about, or the life of about 7 seconds and whatever seconds ago, these two containers have spun up. One is the CLI container for the EKS CLI utilities. And second is the actual kind container, right? The first one actually, which is the bootstrap cluster, the kind cluster running in the form of a Docker container on your admin node as such, right? We can also inspect the kind cluster. We've already installed, like in the previous video we have already installed the kind CLI on this admin node. So we will quickly export the kube config of the kind for this kind cluster, which is generated automatically. So you can see that the export statement says export kube config POC5, which is our cluster name, /generated /poc5.kind.kubeconfig. So this is the kube config generated for this bootstrap cluster in the admin node. And now we should be able to use the kubectl command here to see the pods. We can see that the container, the pods are still getting created inside of the kind cluster, which means there are a lot of activities happening. Again, if you've seen the previous videos, Tinkerbell really works in conjunction with Cluster API and EKS Anywhere. So you can see the presence of Cluster API, cap I pods there, plus cap T pods, which are the extensions for Cluster API. Plus you have the Rufio, Hegel, Tinkerbell, Think Controller, and other ones actually, which are a part of the Tinkerbell stack itself actually, right? What else? So let's rerun the same command to see. No, that's okay. We'll see the pods again to see if the bootstrap cluster. So all the pods have come into action. Let's see if there is any action now on the first control plane node on the, yeah, so you can see that from the, sorry, if you go back there, sorry about that. So we can see that, the components are being installed on the, or have been installed on the bootstrap cluster, and it says creating new workload cluster, which means the actions should be starting on the nodes which are intended to be a part of the cluster, starting with the control plane node. Let's observe the virtual console. So you can see the first system is powered off, and just look back at the graphic that we had shown in the under the hood. The initial power cycle stage has started. for the control plane node, where it will go through a power off cycle, then power on, the BIOS and everything will happen. And then it'll enter into a another recycle, I mean, a reboot cycle, and then start doing the Pixie boot, right? So we will wait for these steps to progress, and we'll keep updating as it flows through. So the control plane node is now booting up. And what you will first see is a set of tasks for BIOS that will be done through the iDRAC. So the admin server communicating via the iDRAC, to set the BIOS and all that. So you can see some of the tasks will start occurring. Once those are over, it'll again go back into a boot sequence or a recycle. So we can see that the control plane is now entering the Pixie boot cycle, Pixie boot requested by iDRAC. And like I said, iDRAC is being instructed, or that feed is coming from the Tinkerbell side, running on the Bootstrap cluster there. I'm not going to go through the pod logs of the Tinkerbell right now. We've done that in the Ubuntu video already of showing the Bootstrap cluster and the pods that run within them and some of the important highlights there. So right now we'll focus on how the sequence works for this particular cluster creation, and essentially proof point the Red Hat cluster actually. So the Pixie boot is starting, and we will see that the DHCP assignment should happen first. So the configuration phase has started for that. The IP address has been awarded .60, 198.60. The iDRAC is 197.60. The hook OS has been downloaded, loading the Tinkerbell hook. Most importantly, the auto.ipixie, as a pathway or a path URL with the MAC address of this node posted on our, admin node, right? So this is the Tinkerbell hosting a web service for downloading the auto.ipixie, which is the bootstrap, to allow the loading of the hook OS, which is an instruction set in the auto.ipixie. And now it will go on with the remainder actually. So the hook OS should come up, and then what should follow is the configuration of the node, followed by the reboot, which will then stream the image. The hook OS once comes up, it will actually execute the Tinkerbell actions, starting with streaming the image that we have given for the image URL. And pretty much that should be it, right? We'll see node by node what happens. So this is an important phase, if you haven't passed in the verbosity, this is the state where you can get anxious, because the streaming image action is happening on the control plane node, and from a log perspective on the left hand side, you see there is nothing. I mean, it's just creating new workload clusters, so you wouldn't really know what's happening, and so don't panic. Or alternatively, keep the verbosity to a decent level where you can know that things are happening for sure. So we have now started the cluster creation with the verbosity kept as V4. Let's see. So the command to actually, build this cluster for Red Hat practically remains the same. We passed the hardware.csv as the inventory as we showed. We changed the cluster configuration file. The validations would first go through. Once the validations are through, the kind cluster is being created right now. So we'll just wait for events to action out. So the kind cluster should have been created here. Let's hop over to the second terminal, and we will export the kubeconfig for the kind cluster. And let's view the status of the pods on the Bootstrap cluster. So we can see that a number of pods have emerged. This is the Bootstrap cluster, not the target cluster. the bootstrap cluster would now start invocating actions on the intended nodes. So maybe we can actually start getting the workflows. If the Tinkerbell has started actioning the workflows, kubectl get workflows -a, not yet, not yet. So let's look at the first control plane node and see if it's undergoing the initial phase of a power cycle, not yet. So the first state that would happen is basically the Tinkerbell would communicate through the iDRAC and then do a power cycle, the initial typical that you saw on the Ubuntu installation as well, right? So we'll just wait for things to happen here. Let's just pause. So the first control plane node has entered the initial power cycle, post which it would get into the BIOS configuration through the iDRAC and then the Pixie boot to follow. So let's wait and we will resume when actions are flowing. So the admin node is now going through the first power cycle. Again, this will take a bit of time. So yeah. Following the boot, now the BIOS configuration is being performed through the iDRAC by Tinkerbell. Yeah, so this will be enumerated as a set of tasks. Let's wait. The second boot is now going to happen following the BIOS changes or the assertions. And this is what we are seeing. The system is powered off on the first control plane node. And then once it powers on, we will expect it to go into a Pixie boot mode. We can see the message there, Pixie boot requested by iDRAC. So Tinkerbell is trying to communicate through iDRAC. And then, the Pixie boot is going to be resumed or invoked. Let's carry on. So let's observe the Pixie boot. It should start with the DHCP request. And then following that, yeah, so the DHCP should happen here, which has happened. The IP address has been awarded here. It's downloaded the auto iPixie and the HookOS files here, right? So now we should enter a phase where it will boot up through the HookOS will be loaded. Yeah, let's wait. So we are seeing the phase where the HookOS is getting loaded now. Okay, let's wait for things to continue. This will now enter into the first set of Tinkerbell actions, which will be executed within HookOS. And that is actually to stream the image, which we have given through the image URL. So now the download of image should be happening in the background. Let's wait for that to complete. And in parallel now, if we see the workflows on the admin node, given that the first control plane is up with HookOS, you can see that the workflow named whatever it is, and the state is running. And this workflow, like you saw in the Ubuntu video, if we describe it, let's describe, Raj, this particular workflow. Yeah, so this is the set of Tinkerbell actions that should be performed on the worker node. If you scroll up, the first action would be the stream image, and that is state is running, and that would download our image. Okay. So looks like the image is now downloaded to the disk. and the other uh, thinkable actions should also have been completed. We should now typically see, as described in the Ubuntu installation also, that this should now load up the OS from the disk itself, and then the configuration of the node would start. Once that is over, the control plane should be deemed as ready. So if we go to the first admin node where the terminal, we can see that this is saying waiting for the control plane to be ready, right? And once the control plane is ready, as you have seen it in the earlier video, the flurry of logs, it will then move to the worker node installation and things like that, right? So yeah, we will see things. So we can see that the control plane has now started booting up from the Red Hat image, that is from the disk. And once the booting occurs and the EKS Anywhere validates the readiness of the control plane, it will then move on to the worker nodes for a similar cycle, right? So let's just wait there. We already saw on the admin node the workflow for the Tinkerbell for the control plane is a success, and I just explained to you what that workflow kind of constituted. Let's wait for this control plane to be ready. We can see that now while the control plane, uh, on the left hand side, waiting for the default CNI to be updated, right? So all these actions are being performed on the control plane, and in parallel, we have now started to see that the .67 node, which is the intended node for the worker node 1, is now going through the initial power cycles, followed by the same Pixie boot and the hook OS, and then booting from the device from the image actually. So now you can see on the left hand side the admin console waiting for the worker nodes to be ready, right? And in that sense, let's see if the second workflow has been created, Raj, uh, on the, yeah, so we'll just say kubectl get workflows. Okay, so we can see that one success workflow, which is the control plane, and then two new workflows have cropped up, and they are in the state running. And these are the individual workflows for each of the worker nodes as such, right? So let's wait for the worker nodes to actually go through their power cycles and the Pixie boot and all that. Okay, right? So we can see the 67 node is undergoing a Pixie boot, starting with configuring the DHCP, which is 198.67, and then the download of the hook OS. So the hook OS has been downloaded, and what should now happen is the hook OS, like the control plane, should be loaded, uh, following the um, execution of the Tinkerbell workflow, which is streaming the image and then the other things. So let's wait for that. Let's see on the third worker node as well, second worker node, so which is undergoing the booting, which will then boot up into the Pixie mode, hopefully. Okay, we'll see. Let's go back to the second node. Oh, sorry, the first worker node. See what's happening. Okay, the hook OS is up. And if we look at the workflows and describe the one of the workflows, I think, yeah. So this one is state running, which is the stream image action. Okay. Let's wait for the streaming of the image, OS images, and that should then lead to another one, which is the device booting from the OS itself, actually. So we can see the .67 node now doing a boot from the Red Hat Linux. And this should now continue to a point where the worker node should be fully configured with the various modules getting installed and whatnot. So we'll wait for the worker node 1 to get over and then hop on to worker node 2. So meanwhile, on the meanwhile on the terminal of the admin node, we can now see the status of the workflows. So the two workflows are now successful. That should be for the control plane and the first worker node. And the second workflow or the third workflow for the second worker node is in running status. We will just wait for that also to get completed till the cluster is deemed ready.
At this time.
So we can see that the second worker node has also downloaded the Hook OS and should load the Hook OS in the sequence. We'll wait for that as well. Okay. So the Hook OS is getting loaded now, following which, the third the third workflow action on the left-hand side, which is in state running, should start getting executed. Now, interestingly, if you want to, you can inspect some of the logs on the Hook OS while the node in the Hook OS loaded state as well. That's okay. We will not worry about it right now. Okay, so we are still waiting for the action. Okay, looks like it's progressing. Okay, so the last reboot action has happened here. Let's wait for it to complete. So we can see that now the second worker node will be booting from the BOSS controller, which is the device disk, and it's booted into the Red Hat Linux. Let's wait for the sequence to get completed and the validations to occur. And then the admin node on the left-hand side should report the worker nodes are ready. What should then follow is a standard sequence of, moving the cluster API components, and the Tinkerbell components to the target cluster and the deletion of the bootstrap cluster. So we'll see all that happening. Let's wait for the sequence. We can also note that all the three workflows now on the bootstrap cluster. We can see the workflows, Tinkerbell workflows are completed with the state success. That means all the three worker nodes are provisioned rightly by Tinkerbell. And now EKS Anywhere will do its own respective follow-on magic. Let's see that.
Ready.
We can see on the admin node, the logs have moved on from waiting for worker nodes to be ready to waiting for cluster changes to be completed, creating the EKS namespace in the target cluster, where it will start hosting, some of the system components, installing the cluster API providers on the workload cluster, because those cluster API resources have been moved on from your bootstrap cluster to the target cluster. So once cluster API is installed, following that cluster API, we are seeing some of the other components being installed. Okay. The last one says installing Tinkerbell stack on the workloads cluster, which is also good as a part of the you know eventual hosting of the Tinkerbell stack. So now you can see in the following logs, you are seeing moving cluster spec to the workload cluster. So now the bootstrap cluster components are moving from the to the target cluster, and the like I said, we don't have in the Ubuntu video that we don't have the licenses for the curated packages, so it'll simply uh, you know uh, you know skip the package installations. It'll install the controller per se, but so yeah, I mean, practically speaking, the cluster is successfully created. So good. And with that, cleaning up the long running container. So if we jump to the second terminal of the admin node, we should, if we say Docker PS, we should see that the Docker containers are deleted. So no Docker container, which means the bootstrap cluster is now deleted. We can now start exporting the kube config for the actual cluster, which is the target cluster. And this kube config should have been generated under the cluster directory. We can see the hardware, and this is what we had, and the machines. These are all CRDs in terms of the Tinkerbell. If we say kubectl get nodes, we can see our control plane, the worker nodes. Raj, if we can do a kubectl get nodes space -o and space wide, small o, space wide, wide, WIDE.
WHY?
No, wide, WIDE.
Why? Got it. Sorry.
So we can see the OS image here particularly, and it clearly says Red Hat Enterprise Linux 9.4 and the kernel version. So yeah, practically we've got now a cluster running with the Red Hat image. So all good. Now, either we go ahead and deploy a small workload. We can see the default pods; they're practically the same. So kubectl get pods -a. I won't get into the details. We've already explained this part in the Ubuntu-based cluster. Kubectl get services -a. The Tinkerbell IP is there, .71, and exposed as the load balance services. So yeah, I've explained the criticality of this, from a ongoing life cycle management of the cluster. Yeah, I mean, let's go ahead and deploy the Hello World application. Okay, so the pod and service is created. It's in a running state. And then let's see a quick log of EKS Anywhere smiling back at us. Okay, cool. So that brings us to the close of this particular video. And like we've tried to kind of deliberate on the workflows again, although we did a much more detailed review of those in the Ubuntu cluster. The same, practically applies to the Red Hat. But this is essentially, like I said, a first ever video where we have shown an end-to-end Red Hat based cluster for EKS Anywhere deployment on a bare metal basis, right? So I hope you enjoyed, and it kind of gives you the confidence to go ahead and forge your strategies with Red Hat on EKS Anywhere on a bare metal basis. Thanks a lot again. Thanks, Raj. Thank you. Cheers.
Thank you, everyone. Bye-bye.